Hello, hello, hello. Welcome to Enlightning. Thank you for sharing your time and your intention with us. And Tim Bannister's here to teach us about validating admission policy for Kubernetes. Tim, tell us about
Hey,
yourself.
hey, Whitney. Yeah. I'm a Kubernetes contributor. I'm an award-winning Kubernetes contributor because I got a couple
Woo.
of awards for contributions to SIGDocs. None of them I got to pick up because they happened during the the big pandemic, so they got mailed to me
Uh-huh.
eventually. Um,
What are
but
the
like,
awards specifically?
where do I work? I work
No,
for a
no,
Oh, the
what,
awards.
yeah.
So top documentarian, which was like a KubeCon
Ooh,
award,
nice.
and like a outstanding contribution to docs.
Amazing. So like one particular contribution was especially good and that one got singled out.
I think it was like these are awards that we give out as a project to recognize different levels of contribution.
Cool.
So at the at KubeCon North America, we hand out
Uh-huh.
as a project like the annual awards, and there's a documentation category to
Uh-huh.
recognize people that have these got added a little while ago to say, hey, these awards, we didn't just want to recognize code contributions. We wanted to say there's other ways for people to contribute than writing code. And I got one,
Yeah.
which is super good.
That's amazing. Is it on display in your home?
It is. I did consider going to get the thing, and I thought that would be too much, so I haven't gone and picked it up. But yeah,
That's exciting. Congratulations.
one's on the
So
wall and one's on the shelf because they're different shapes.
that's very, very good description, as I would expect from a documentarian such as yourself. So tell us, like, what's your involvement then with validating admission policy?
I reviewed the docs on this, and it
Okay.
turns out I've been recommending it to a lot of people and saying, hey, this problem you have in a few years when this goes generally available, you're going to love this
Uh-huh.
simpler way to solve it. I didn't write
Ah.
any of the code. I don't really write code for Kubernetes. I tell
Uh-huh.
people how it works, or increasingly, I help other people do that job.
Nice. That's kind of where I've been living my space too. It's a very valid space, I think. Well, of course, I'm going to say that I'm a little biased, but when I wanted to do a show about validating admission policy in Kubernetes, I looked for who was talking about it in Slack, and that's how I saw your name. And for a moment, just for like I'd say maybe 2 or 3 months, I hung out in the SIGDocs world and came to all the meetings and contributed a little bit to SIGDocs, and so I knew you from that. Not in a personal way, just because you're a bit of a leader in that space. So you were leading some of the community meetings that I was a part of. And I was just like, oh, Tim, he seems like a good person, like a kind and good person, and also good at describing things. So that's how I came to ask you to be the guest. So thank you for sharing your valuable time with us.
Well, thank you for the reason that you saw me in those docs meetings is all your contributions. We do value that way of contributing to Kubernetes and all the other ways people contribute.
Yeah, we were talking in pre-show, you and me, about I so back when I was doing that was maybe 2 years ago almost, and back then I was very shy and kind of intimidated by everything Kubernetes. It's a lot, and so I did learn the Git practices around contributing, but I talked about like kind of what a big barrier it was in the first place to get through that licensing agreement thing, sign that particular thing, and then just like figure out like, okay, how does the Kubernetes project like to use Git? Like, what is Git? How does it work? I mean, I knew a little bit about Git already, but so how do you think? And your response was people shouldn't have to learn how to use Git just so they can fix a comma. But have you given like how would that work for someone to be able to make a contribution without the checks and balances that Git provides?
I guess I want a way to have checks and balances so that you can't scribble over the live site, but make
Uh
it
huh.
even easier than editing Wikipedia.
Oh, Wikipedia is like a nice model to be able to use. Yeah. Yeah. That's a Is that like a pipe dream, or do you have any like steps on how that could happen?
So I guess there's two pieces to what I'm imagining. One is that like Git is not the end of the journey. So you've worked on collaborating with Git and you've worked on collaborating with Google Docs or some of the clones like modern cloud Microsoft Office. You know that Google Docs has these operational transforms and clever engineering, and the user experience is, hey, we can both edit. And it has these clever engineering, and the user experience is, oh my gosh, I need a training course to learn how to fix a comma. And I don't really mind how the engineering is going, but I want that experience of people collaborating on documentation. And I want that not just for docs. I actually would think that that would be a good way for people to collaborate on code.
Amazing. Say more about that. Yeah.
You know, changing, you know, an open source community to move from Git to something even more flexible. It's not a small undertaking. I know how I want it to feel, but I don't feel I have the time to contribute to making that happen.
Yeah, it's a lovely thought. I hadn't considered it, and I like to hear. It's a really cool idea. We have a couple folks in the chat, some friends. Kormaju's here. Hello, Kormaju. Thanks for being here again this week. And Fuel Snobel's here too. Hi, Fuel Snobel. Fuel Snobel is... Kormaju asks amazing questions. Fuel Snobel will give us some very colorful commentary. That's how do you feel about how I summarized each of you two, Kormaju and Fuel Snobel? So I'm going to start moving behind the board. But one thing you said, we were talking pre-show, and one thing you said that I'm like, don't tell me now because I need to hear about this live. You said you know the origin of how light boards came to be, like how they came to be. Well, I don't know any more than that.
So I've seen it a little bit. I can talk about that, sure.
Yeah, please do. I'm going to drop, before you do, I'm going to put some links in the chat. One link about you, and then 2 links about validating admission policy. And folks who are here, yes, folks who are here, I would love to hear about what y'all are doing, like who's using a policy engine and who uses it for validation versus using it for other things. And if you're using it for other things, what are those other things? That's the question I have for y'all. And even if you just want to say hi and where you're from, I love saying hi to you back. All right, I'm going to drop these links, and Tim is going to tell us a juicy story about how lightboards came to be.
Yep, that's got in.
Yeah.
So let me tell you what I know about how people came to be writing on lightboards.
Yeah.
I know this because of the Cold War.
What? The Cold War?
Yeah. So I'm old enough to remember having sirens on the top of public buildings. I'm old enough to remember that the I guess you could call it the 4-minute warning, and that's what we call it in the UK. The threat of Armageddon from above. So people were quite worried about this. And when people were worried about this, they decided that they needed radar. They needed air defense. They wanted to know when the bombers were coming. They wanted to know when the missiles were coming. They wanted to know what was going on. And these days, you'd probably use a computer. And it's probably a very old computer because people don't like to turn these systems off and upgrade them. That's the thing people try and avoid doing. But before they had computers, they had aircrew. They had people who worked for the Air Force, and their job was to go and stand behind a sheet of glass with the right kind of pencil or the right kind of pen, and there'd be some lights coming in from the sides, and they'd be told, you need to draw that unknown contact there. And so they were basically being like a human screen. And then they'd rub this out, and the bomber or the unknown contact, the unknown flying object would move, and they'd draw it again. And I've actually seen one of these. So there is a place in East Anglia, the east coast of the UK, where an old radar base was shut down, and a lot of these bases were kind of emptied out. But this one, for a few reasons, they preserved it. And they've actually left the display screen, and I don't mean a computer screen. I mean a bit of glass with some China graph or whatever showing on it. They have left that in place, showing the board exactly as it was the last time that someone from the armed forces was there drawing up the known threat picture.
Amazing. So who's consuming this picture and from where?
So, I mean, this whole thing originates from, this was invented in the 1930s by a few countries, but actually Britain did really well at it because of the invention of radar, which was a secret at the time. Radar was a complete national secret. It wasn't something that anyone talked about. They didn't want the other side to know that they had it. But they didn't just invent the radar. They didn't just invent the set that would tell you, how far away a contact was. They invented all the processes, the information processing that would let people know, what contacts were coming in and what was going on. And one of the first uses of sort of complicated pattern solving was actually in computing, was actually to build this picture in a better way, to replace a room full of people. You didn't just have the aircrew with the pens behind the glass. You had ranks of people where there'd be someone right at the front row. We're doing basic information processing, getting the basic radar data and processing it. And then kind of behind them, imagine you're at the cinema and you're sat behind, you've got a screen, and then the people in the front row of the cinema are doing the basic processing. But the people in row 2, they're doing more abstract processing. They're assigning meaning to what's going on. And you move further back until you've got like an air chief marshal or whatever that the rank would be, and they're saying, right, I give you the orders, like scramble.
Wow. Yeah. I would have. When I was like, tell me about how light boards came to be, and you're like, the Cold War. Like, I was like, what? That's very far away from what I expected. We have some folks to say hi to. Tiffany's here. Hi, Tiffany. Thanks so much for being here, friend. And then Kormaju has a question. I think Kormaju's been checking out the Tim link that we put in the chat. So with the SME Pro certificate, what do we learn? Before you answer that question, who issues the SME Pro certificate? Those of us who don't know about it, will you tell us what it is a little bit?
Sure. So this is something I can talk a little bit about, but there's a non-disclosure agreement about the detail. So you may or may not get to hear what you want there, Kamaji. But there are a few organizations that set professional exams, and they get people from industry to help write the exams. And that's called subject matter expertise. So I do 2 SME programs. One of them's for Amazon Web Services. So I've participated in exam setting and exam question review for Amazon Web Services at the pro tier. And I've also done that for IISSCC or ISC squared. But I can't really tell you what that's about because I've promised those organizations I won't do that. Sorry.
You're so exciting and mysterious. Hello so much. Thank you so much for coming. So every episode at this point, I'm a relatively new learner. And I like to start with what is the context for why this tool should exist? And what's amazing right now is that I'm here, this moment is the context. What was the world like before your tool existed is usually the opening question. But that's the world right now. And that's exciting for me. That means I'm catching up, I think. So what problem is this solving? Is validating admission policy solving? Or what other context do you think we should know before we really get started digging in on the tool itself?
Cool. So I'm interested in what people's experience has been of some of the things you asked about, like validating admission webhooks, about using policy engines like Gatekeeper and Kyverno.
Kyverno.
Kyverno, sorry. I think one of the problems that this solves is my cluster is broken and I don't really know why and help problem that people don't want to troubleshoot.
Well, is it a matter of unwillingness or kind of it can be really complex, you don't even know how or where to start to troubleshoot?
I think I think people end up in a situation where they've installed something on their cluster, and what they've may have installed is an operator, and they might have installed a controller, and they might have just installed a Helm chart. And people have done this. Maybe people, in the chat have done this.
Uh-huh.
When you install an operator, you don't think, I need to learn how to troubleshoot validating admission webhook failures. But you kind of you sign up for that without finding out that you needed to.
Yeah.
Which is a complicated way of saying that validating admission policy lets you achieve the same outcomes without having to worry about this thing called a webhook failing.
So, so Kubernetes validating admission policy will help you troubleshoot cluster issues without having to learn about webhooks. Is that correct?
I would say that
summarize what you.
So, I mean, there are problems that lead people to want to use the expression language, which I'm not going to talk about in a bit, in Kubernetes, and want to validate things. And one of the common reasons to want to validate things is because you're using an operator, you're adding a custom API into Kubernetes. I'd say that's the number one use. Custom resources and custom APIs.
Because doesn't Kubernetes have its own admission controllers built in for Kubernetes resources?
So Kubernetes does admission time validation for built-in resources its own special way. So this is like an important sort of supporting point, I think, to get that you have built-in APIs. So you have pod, you have ingress, you have service, you have network policy, you have role and role binding, and we could go on for a long time just listing all the internal APIs. And they are different, and that how they work is not like custom resources.
Okay.
And when you send in if you send in a valid resource, like the validation isn't important, like it works. So all of the interesting stuff happens when you send in something that's not valid.
Yeah.
So maybe you try and specify a pod that has an init container, and you've specified a readiness probe. Well, unfortunately, you can have a readiness probe on a container, but you can't have a readiness probe on an init container, just for reasons. And so Kubernetes needs to say, no, that's not okay. That's not valid. And that's done by the API server, which is this massive lump of code that makes Kubernetes what Kubernetes is.
Yeah.
And the API server doesn't offer that for custom resources.
And so when we say a common reason to want to validate resources is to validate custom resources, is there anything in particular that we're especially looking at when we're validating these resources? Because it can be so different. Is it a matter just of schema, or is it a matter of like compatibility with Kubernetes rules, like the one you just mentioned? You can have a readiness probe on an init container.
So this kind of validation, this isn't like company policy. So you can use things like Kverno for company policy. And I will come to that, I promise you. But right now, I'm talking about extending your cluster. So let's say you want to deploy Prometheus, cracking CNCF project that does monitoring. You probably got people who've watched you talk about this watching a stream right now, and you installing Prometheus using the operator for it, which is a great idea because we like using robust automation. We like being cloud native. But if we're being cloud native, then when you specify that you want to have Prometheuses and alert managers and so on, something needs to check that you've got that right. And this schema is done in two ways. There's
I have a quick question.
Go ahead.
So is the something to check that you've got that right? Is that responsibility probably falls on the project that's putting the custom resources into the cluster? Or does it fall on the user who's adding the custom resource?
I'm not. So the way it usually works, let's say with Prometheus, is that someone gives you like a packaged Helm chart, and you kind of look at it a bit and make sure that there's no malware in there, and you check the prevalence, but you're not looking at the code. So long as it's from Prometheus and you trust it, you're like, okay, Helm install.
You scan it, you make sure it's signed, and then you put it in there. Yeah.
You don't look at how
Yeah.
it's done, because that's the whole point of an operator. Like the whole point of the operator pattern is to let you do powerful things without caring about how they work.
So when we say the most common reason to want to validate resources is for the projects who make custom resources
So
to
the people who
make
are going
sure
to
their
write
own.
these, the people who are going to write these validations are the Prometheus project or
Okay.
the Kafka operator project.
A CRD is right, the validations. And then are the validations included as part of the package of the project?
So I don't want to answer that question quite yet. But
okay, I love it.
I want to answer part of that question. And I want to say that in the future, it's going to change. So what happens right now is that you install a Helm chart and it sets up a couple of pods, and those pods run a service. So this is only about what the old way. This is not about validating admission policy. But you have a couple of pods, maybe like a deployment and a replica set, and they run a service. And that service is a webhook responder. And then the API server sends a message to that webhook to say, is this a valid Prometheus? Is this a valid alert manager? Is this a valid sausage?
Right on. And do you think, I'm going to say, hello, Code with Sean. Thanks for being here, friends. Do you think that's, what was the question? So that's how, do you think I should capture that on the board is the question?
I think I would capture, like, you might have to rub it out, but I'd capture it for now at least and let people see what we're talking about.
When I was new to this medium and this format, I could think of at least one time I've had a show where I had to erase some stuff to make room for other stuff, but haven't in a long time. Right now I have a streak going. So the old way would be a package.
Let's not talk about the Helm chart. Let's talk about what you get after you deploy it. So you get a deployment and you get some pods.
For your custom resource.
You get the custom resource, and then supporting that, you have this webhook thing.
So custom resources, it makes a deployment.
The installer, whatever it is, makes a deployment and a custom resource. So the custom resource is not managed by the deployment.
Okay. The custom resource is deployed, and among other things, it makes web.
It makes the API called. It makes it the API called a deployment with like the capital D deployment.
Okay. Which resource that it makes is relevant right now? So you said a service.
Let's start with custom resource definition. That's the key thing for like if you haven't got one of them, you have not got an operator. So let's have a custom resource definition.
Okay. And then when I wrote CRD up here, that's what I meant.
Same thing.
Yeah. Okay. And a custom resource definition is basically a schema, right?
Yeah. It's a schema and some other stuff that is probably a whole other talk. But it's basically a schema saying I'm going to have this extra API in my cluster that wasn't there like a minute ago. And like there are bits of Kubernetes, like so when you were talking about ingress, when you talk about gateway on your stream, like gateway is a CRD that doesn't appear until it turns up.
Okay. Yes.
So the gateway project could use this mechanism.
Okay.
But right now the gateway project doesn't use validating admission policy. If people are working on gateway, they use the old way. They use something else. They use validating admission webhooks, and that's what we're drawing here.
Yeah. So right now, the old way, a custom resource is deployed, and among other things, it makes a custom resource definition. And what else?
Yeah. Let's say a deployment.
Okay, capital D deployment.
It's gonna make two deployments. It's gonna make a deployment for the controller, and it's gonna make a deployment for the webhook handler.
So the controller, its job is to make sure that whatever is defined in the desired state is equal to what's in the actual state.
Yeah.
And what's the webhook handler's job?
So the webhook handler's job is basically to make sure that the controller only asks for things that make sense. Validation. So like valid inputs, basically.
Yeah, it only gets valid inputs. I wonder what it would be like to have that in my life, that only reasonable questions are asked to me. Or if really it should be put on me, so I'm only allowed to ask reasonable questions. So that's validation.
So if anyone's had that terrible interview experience with like FizzBuzz, I feel like I've never done this, but I've thought of making a FizzBuzz CRD, which lets you put in like any number, but you can have like 1, the number, 2, the number, 3, the number. Oh, hang on, didn't I have to check whether things divided by 3 or 5, and I'd get a validation failure.
Nice.
And so, if you had the FizzBuzz operator and you said, okay, the value is 3, the controller wouldn't be like, oh yeah, I know what to do with that. Like, you've given me the wrong input. I can't FizzBuzz you, and it would fail at validation.
Okay.
And to make that work, we need some pods. I don't know how much you want to draw up, because like maybe we can just assume that deployments work the way they normally do.
Okay.
But we need a service, and we need a validating. What are they called now? Validating webhook configuration? Yeah, I think that's right.
Okay, so the webhook handler is going to run its workload in pods, and those pods are going to communicate through a service.
Yep.
And then what's the third thing?
I'm just Googling it to make sure I haven't got the name wrong, but I think it's called validating webhook configuration. Yeah, it is. I haven't forgotten.
And so that's validating. This is great. Webhook. Configuration. So this is a resource, a Kubernetes resource.
Yep, validating configuration is another API like deployment, and yeah, it's an object API. So every validating webhook configuration is a resource that you can talk to it using HTTP, and you can look at it. Cool. And really, validating admission policy is going to be a replacement for that. Not a full replacement, but a good alternative to this.
Okay. And so, what's the validating webhook configuration do?
So the validating webhook configuration tells the API server, hey, if you see someone make a change to Kubernetes that matches these rules, send it here for checking.
Okay.
And it has to be a modification, like a patch or a write, a create. It doesn't happen for reads. You don't validate reads. They just read back.
Yeah, that makes sense. So it tells the API server, if a request matches these rules, ask for my approval, basically.
Yeah.
And so somewhere along the way, someone said, this validating webhook configuration has some problems that we can improve upon. So what are the problems of doing it this way that the world wants to fix?
So let me give an example from AWS, which is the technology that we work with most at the Scale Factory where I work.
Okay.
So AWS have made and are, they're looking at donating this to the CNCF, I think, but they've made a thing called Carpenter. This is just an example. And Carpenter, it starts with a K because everything starts with a K.
Of course it does.
So Carpenter has a bunch of CRDs. And what the happy path is that you put in place a provisioner CRD, and you put in place an AWS node template, because right now the only supported cloud is AWS, but that's changing. And you define, in this case, a provisioner and an AWS node template, and this thing has the job of finding the cheapest way to run your workload on the cloud.
Oh, cool.
So if it's running nodes and it goes, hey, I found a cheaper way to run them. This price has changed, or some pods have shut down, and you don't need this node anymore. Then great. Carpenter will come along and spin up some new nodes that are cheaper, and then shut down the old node, and Kubernetes will take care of all of the things, and you end up with a cheaper cluster. It's auto scaling for the nodes. And it's done using custom resource definitions and a controller, and there's webhooks.
Yep.
Now, the default out of the box doesn't have this problem, but you can set it up wrong. And imagine that, just as an example of how you get this wrong, Carpenter's job involves deleting nodes. Imagine if you didn't tell Carpenter to protect the node where the webhook's running. And you've got a webhook that says, hey, before you add nodes, I need them to make sure they look like this. I'm only going to allow this kind of node. And you didn't tell Carpenter, and you didn't protect it with a pod disruption budget and so on, that your node validation webhook needs to have at least one copy running at all times on two different nodes, or whatever. And now you've got a problem. Because you've got a thing that has to check every new node that's being added. And Carpenter would love to make some more node to run to run the new copy of things, but it can't. And it can't because the thing that checks the nodes isn't running.
So, but wouldn't you have the validating webhook configuration as a Kubernetes resource? So wouldn't the control plane, wouldn't that be persisted in etcd that's then persisted in many different places? And how would you lose that?
You keep the webhook configuration, but when Kubernetes comes to talk to the service, what the problem is, instead of it finding, hey, yep, there's two valid pods for this controller. Oh yeah, good. There's two pods there. That's great. Okay, and I also need to check the node. Let's check the node. There's this other validating webhook configuration that the cluster operators put in. I'll just check this node and see it's valid. Looks good. Yeah. Hello. And there's no pod responding to that validation webhook.
So
now you go on.
Yeah. So one of the problems, at least with validating webhook configuration, is it's the consequences are disastrous if that webhook isn't running for some reason. Is that the right way to capture what you're telling me? Yeah.
So the dilemma is you've got two options as a cluster operator. You can have it fail open. And so with fail open, when the validation isn't running, everything is allowed through. And then you don't have that problem. But you just failed open.
Yeah. Then you just
so maybe this was a security rule.
Yeah.
And someone's going, okay, I'll just wait until there's an outage on this cloud, or they do some maintenance. They do maintenance 4 a.m. Okay, I'm a criminal. I'm going to wait. 4 a.m. Okay, the maintenance is happening. This is a great time for us to try our thing. Oh, it succeeded.
Yeah.
So that's why it's a dilemma.
Will you help me capture that? Your example was nice, but will you help me capture that in words?
I will certainly try.
Okay.
But I think there is this dilemma between fail open and tolerating pod failure for the webhook.
Failing open, so letting
failing open, and the security consequences of failing open.
I guess I don't. The dilemmas between failing open is failing closed a thing.
Failing closed, yeah.
So the dilemmas between failing open versus failing closed?
Yeah, so failing closed has availability consequences, basically. So instead of, people maybe being able to bypass your security controls, your cluster isn't running. Like, you can end up literally with no nodes, no healthy nodes, no pods running. Everything is bad. And part of my job, we go on call for some of our customers as sort of a second line in case they're really having some trouble. So I don't want a customer to end up in this situation because I like my sleep.
I'll be interested to hear how validating admission policy solves this.
Yeah,
so that's
let's
one
talk about
problem. Yeah. So is this the problem, really?
Well, I mean, you've been talking, on your stream about other uses for the old way, and we can talk a little bit about that, I think. So people don't just use validating admission webhooks and their cousins, the mutating admission webhooks. They don't just use them to make CRDs work and to make operators do the validation. The other use is for like your corporate policy.
Yeah.
And I've kind of hinted at this. It's the same kind of, the dilemma is the same, right? The use case is different.
I'm listening.
Yeah. So the use case is different. But the dilemma is the same. In fact, for some operators, you might have an operator that's Prometheus, and if you're a company that is running stuff in the cloud, and the only thing that happens is that your observability goes offline for a whole weekend, that's actually okay. Hey, I'm going to need a drink.
Yeah.
Getting a bit croaky here.
I have a lot of questions. I'm making you talk a lot.
So I was talking about, if Prometheus goes online and it goes offline and your operator has gone offline at the weekend, you can live with that. You'll want to fix it, but it's not the end of the world. But if you lose one of your key clusters, or you break, a key aspect of your workload, maybe no services can be created. No endpoint slices can be created. There are things that you can break all of the workloads all at once.
And is that something I should write here? It's like as one of the problems for the old way?
I think so. Like when you're doing policy validations for organizations, failure can be catastrophic.
When you're doing organizational validation.
Because it's catastrophic, it's scary. And one of the things people might say is, I'm not going to do it. They might say, well, I'm going to do pod security admission and I'm going to stop there. Or I just, our team doesn't have the confidence to put these controls in, or whatever. And that's unfortunate. Like,
and that's
as a
definitely,
project,
that's definitely something we talked about with I think all of the policy tools that we've recently covered is how powerful policy is, and therefore it's dangerous. And even like talking about to implement policy, you start small and safe and then grow very slowly. You don't like immediately put in a big policy out of,
So I will say that validating admission policy gives you, if you like, a foot gun. It gives you the same level of sweeping control to break things. But they are easier to fix when you do.
Okay. I want to write that down, but I think it'll make more sense to capture it later.
Sure.
That's funny. All right, so let's talk about how validating admission policy. Well, first let's write up a definition for what it is. What do you think about that?
I was thinking you were going to leave room for like the new way, because you've just got to like a nice space level with the old way.
You're right. Yeah, let's do it. I love it. All right, the new way.
So you don't need a webhook controller. You don't need pods. If you want to validate something, you need a validating admission policy. That's all you need.
Validating admission policy. You don't need a controller. You don't need pods. Cool.
What you do need is a binding, and deep breath here, validating admission policy binding.
It's just a matter of time until these things become abbreviations. Yeah, the RBAC style.
Yeah, but you try pronouncing VAPB in like.
You do need. So besides the policy itself.
Yeah. For it to be useful, you always need these two things.
This doesn't lend itself well to this medium. Validating admission policy, validating admission policy binding.
Yeah.
So I can guess at how this might separate concerns.
Cool.
You would have the policy itself, which would have like some sort of rule that you have to follow and consequence of that rule. And then you would want to be able to use that policy in lots of different ways. And so the binding would probably be like binding it to a web, like a namespace maybe, or a certain type of resource maybe. Yeah.
You're exactly right.
Cool. What would you have said?
Well, like that that's how I'd explain it. Yeah, you need those things. That is the split. You've nailed it.
So separate concerns between the policy itself versus where and how it's used, right?
So bindings allow reuse, and there's another thing I'm going to call out that, like, in a bit we're going to talk about a more complicated use case where you can set parameters. But I don't want to go down that route yet because there's plenty of complexity here already.
Yeah. So is even separate? Should I just say what you said about bindings allow for reuse instead of separating concerns? Okay. And then let's maybe define what these are. I still love a good like validating admission policy is.
Yeah.
Validating admission policy binding is.
So I'm not sure if I can do a short version. I'll give you the long version and we can see if we can make it shorter.
Okay.
But the what a validating admission, I wouldn't write this up yet just because I'm thinking out loud here.
Okay.
A validating admission policy is it's a declarative way to express a fully declarative way to express some rules about what is allowed to change in a request, something like that.
I like it. Validating admission. Oops. Oh, one word.
Yeah.
Policy is a fully declarative. Why do you feel the need to put the word fully in there?
Well, so validating webhook configuration is declarative, but then as part of its validation, it says, okay, I'm declared as in someone has used the declarative API to specify there's a webhook, but then it goes off on a webhook, and the webhook could be some JavaScript code.
Got it.
It might be
I think.
Caverna, which is declarative, but it might we don't know what it is.
Uh-huh. So webhook itself might be imperative.
Sure.
So when we say fully declarative, okay, it's a fully declarative what?
That's like, what did I say? Something like means to define rules about, or like, yeah, way to specify rules about what changes clients can make.
Is it to define rules about what's allowed to change in a cluster?
Yeah. There's two details. So like you can think of these in two different ways, and I think they're both good mental models to use depending on what you're doing. So one mental model is to say, I wouldn't write this either because I'm still thinking out loud and we're still working on it.
Yeah, I love this.
We are defining how the cluster can end up, how the object can end up. But another way of looking at it is actually, you can, for example, say, you could implement traffic lights. You could say this can change to green, but only if it's previously been red, and this can change to red only if it's previously been green. And then, depending on which country you have, you can have like the UK's rules where it can be red and amber at the same time. And then you can say, no, now we're in Italy and it's different rules. And you're essentially, you can build a state machine validation rules with a validating admission policy. So that's not just about what data can be in the cluster, it's about what changes are allowed.
What is allowed or not allowed to happen in a cluster?
Yeah. But not to a cluster, to one object. You only ever validate an object in isolation. So I can see that the old, traffic light value was red, and I'm going to change it to green. But I can't have a look at the next junction along and see if that, and make sure that these two are interlocked. So it only happens, an object. One object gets validated, and I cannot have a look in a validating admission policy at any other object while I do that.
Isn't that wildly tedious to have to deal with it at an object by object level? Like, wouldn't you want to be able to say an application can only have so many replicas associated with it, regardless of where those replicas are defined in the autoscaler or in the deployment?
So as a rule, I can express this. Let me explain two different scenarios. If I just want to say every application in this namespace has to have at least 2 replicas, I can do that. But when application A gets evaluated, the evaluation doesn't look at application B at all. But I can, if I'm doing bad architecture, I can write a webhook that says, hey, when you're trying to change application B, have a look at the value you think application A most recently had and see if they add up to a number that's bigger than 7 or whatever. And you shouldn't do that because that's not how the Kubernetes API works, and you can end up with a lost update. But you could try with a webhook validation
because it's imperative. Once you get the code in there, well, you can just do whatever you want. And be a big old mess. Okay, so are we happy with where we landed with our definition? The validating admission policy is a fully declarative means to define rules about what is allowed or not allowed to happen to an object.
Yeah, I'm happy with that.
To a Kubernetes object? Okay.
Yeah. An object in Kubernetes. How about that? Then you don't have to rub anything out.
All right. So we have a policy. Now what's a binding?
I'm not sure I can even be as succinct as this, and that's a big block of text. But it tells Kubernetes where to use it. How about that?
You were very succinct.
I think I'm too succinct. Tell you what, leave lots of room. Have it there, but then leave lots of room for some more detail to turn up later.
So a validating admission policy binding
tells Kubernetes where to use the validating admission policy.
Is it where or on what or both?
I think where, like namespaces, for example.
Okay.
So you're not necessarily specifying objects. You're saying objects in this space.
And then I have another question. Is it where to use a validating admission policy, or where to use it? Can it control more than one validating admission policy at once, or is it a one-to-one?
It's many to one. So you can bind a policy, with two policy bindings, but a policy binding refers to a policy.
Okay. That makes sense. Okay. I won't put a square around it yet. This will be either room for my head, or we'll end up writing over it with a definition.
Why not both?
Cool.
So what we haven't talked about yet, and what you maybe want to cover next, is what happens when you try to do this. Like, what does failing validation look like?
Yeah, you said that's where it gets interesting, is where it fails.
Yeah. So the happy path is you try your right and things happen. It's not a very interesting story. The unhappy path, and webhooks have this too.
I'm listening.
The unhappy path doesn't have to be that unhappy.
Mm-hmm.
So one thing that Kubernetes lets you do is you can send a warning header. So I can write a validating admission policy to say that in my config map, I want all of the keys to be camel case. And I can try and write a rule in validating admission policy to say, okay, make sure that for a config map, every key is camel case. And then when it doesn't, you just get a warning. And you try it with kubectl, and kubectl prints a warning saying you didn't use the right case. It still goes in.
And is that, I guess webhooks can be anything. So it's not, we don't really necessarily want to compare it to that. So can you help me with, like, are we on to, just in terms of organizing the information on the board, are we on to like benefits, like additional features of the, help me, how will I capture this? How shall I capture this?
I think it's, I would capture, like, the actions as a key detail.
Okay.
I think that the benefit is really by comparing them to the old way, because they are so widely used. Validating admission webhooks are how people solve this problem today. They're what everyone knows who's got this problem. And you have to be a brave, cluster operator to use this alpha feature in production.
Oh yeah.
You have to be a very, very brave and kind of lucky operator, if or cluster admin, if not only have you got it enabled in production, but then the thing you want to install is like, oh yeah, we also have a version of this Helm chart that supports that. That's just, it's too early. It's not even beta.
Yeah. Maybe that's worth saying. Alpha feature. Both of these are really. So what was this? What was the first action you said? Like, it gives a warning as opposed to a failing.
Print a warning is well, if you use kubectl, it prints the warning. If you use another tool like Helm or Customize, you might get a different outcome. But kubectl will print a warning.
As opposed to failing outright.
Yeah, succeed. Like the change goes through.
Oh, yes. Got it.
So another thing we can do, and this is not exclusive, we can write an audit record. So, maybe we're just interested in finding out who's doing this thing because we're going to deprecate it, or we want to know if we're going to deprecate it. So we can write an audit record, and it goes through, and we can write an audit record and print a warning, and it goes through. We can just print a warning, and it goes through. Or we can do nothing, but that's not really that's called not having a validating admission policy. Don't deploy the binding.
Okay. Is there anything more to say about write an audit record?
Not really. I guess if that's new to you, look up auditing in the Kubernetes docs or go and find a good YouTube video on it. Did you do a talk on this already? I can't remember.
We talked about it in the Kyverno episode. We talked about you can make policy reports and scrape them and customize them and send them to certain people. You might, or access control over who can see what within the policy report. But basically decoupling the policy from the results of the policy.
So I guess it's worth mentioning then that Kubernetes can write audit logs, and that's completely separate to validating admission policy. But if you haven't got audit logging turned on, then when you tell it to write an audit record, nothing actually gets written.
So Kubernetes native audit logs.
Yeah.
Cool.
And those, I will just mention those can be to a file on your API server node, or it can be sent over HTTP. You don't that's just for people watching the stream, really. I don't know if you want to write that down. It's up to you.
Okay. It's happening. Okay.
Cool. And let's talk about the obvious third action, which is to deny.
Deny the change.
Deny the change. It does not happen.
And then I guess there's accept the change without a warning too, right?
You have to set a failure policy. Let me just. I think you could. Yeah, so you can. It's not very useful to write a policy that ignores changes, but you do nothing as an option. But why?
Okay, we'll leave it off.
So you can combine these things, so you can combine denying the change and auditing that it was denied, and auditing it. Those can be combined.
Are there any? So this star is at the bottom here. I'm going to write not mutually exclusive. Let's see if there's room. And are there? Can you combine literally anything with it? Literally anything, or is there anything that doesn't?
Well, printing a warning and denying the change isn't going to be very useful because you print a warning on the accepted change. You can specify it, but it's not going to give you an outcome that's useful.
Cool. We have a comment from Cormaju. Validating admission policy looks like error handling in a programming language.
I'll tell you what it reminds me of. There's an assert statement in some programming languages. So you might have this just for debugging, or it might be part of your production system. But sometimes you can say, assert. And that's I think we should probably look at the policy language now, which is called CEL, and we can talk about how that looks like assert statements.
Cool. So what is, I know what CEL stands for because I did my homework. It's Common Expression Language. Let's say what it is first.
Okay. So we're going to use the word declarative again.
Okay. It's common expression language.
It is an extensible Low overhead, I would say. Declarative language for expressions, expression evaluation.
Declarative language. I hear you're like you're documentarian, like you shouldn't use a word in the
Yeah.
For expression communication, for expression definition.
Evaluation.
Expression evaluation. Cool. Extensible, low overhead, declarative language for expression evaluation.
Yeah. So some of the things that make it really handy are that it's declarative and it's not Turing complete. It can't let you write general programs in it, and that's a good thing for Kubernetes. Even if it's a frustrating thing for you as someone who's writing the policy.
Interesting. I want to hear more about that because, well, I do anyway, but like I believe 2 weeks ago we had an episode on KubeWarden, and their whole thing was that you could write policy in a language of your choice and use all the logic in the language to your advantage. So it's interesting that you'd purposefully make it so that it's not accessible.
I think both of these things have. I'm going to go off on that tangent. I think both of these things have a really good place to play. So
Yeah.
if you want to write policies in a language that you know, then you can write a policy engine in Erlang or Rust or JavaScript, and you can use that. But when you're using that, you're not imposing any sort of costs on people who use the API server. These things run in your control plane. And so if we let you run arbitrary programs there, someone would start mining Bitcoins.
Yeah. So cell is Turing incomplete. Is that Touring?
It's like Alan Turing, Turring. Yeah.
Okay.
Yeah.
Meaning you can't write programs with it.
You can write specific programs, but you can't write general programs. I don't think there's any looping.
Okay.
But what you need for Turing completion is like looping and branching, a couple of other properties, I guess. But you get branching, but you don't get loops.
Good, because you don't want to put that kind of load on your Kubernetes server.
It protects other API server users from mistakes or malice.
Mistakes or malice. I haven't heard that put so succinctly before. Sometimes we talk about policy and assume a bad actors, like that's what you're protecting it from. But just as much, if not more so, you're protecting it from good people who make mistakes.
Yeah. One thing I look forward to about this simpler mechanism that doesn't come with as many ways to break your cluster is being able to delegate more and trust users more and say, sure, if you want to put a policy in like that, we'll give you a way to define it because it feels safe.
I like that. Nice. So
go on.
Is that related to when you say failure can be catastrophic with the old way? Is cell part of what protects from having catastrophic failure?
The design, like, you know, the design here took, you know, thought about different ways that people could get it wrong, and you are still given enough power. You can write a validating admission policy or a set of validating admission policies that kind of lock your cluster down and mean that you can't do anything.
Mm-hmm.
There are some get arounds. Like, you are always allowed to delete validating admission policies, because the one APIs, the APIs that you cannot change are validating admission policy and validating admission policy binding. They're exempt from these changes. So
Okay.
there's like a safety feature there.
Should I capture that?
Maybe above the asterisk in the middle column. That way, yeah.
Should I move? I was going to move the asterisk up here if we're done talking about the actions, or deleting is an action.
Well, it's kind of related, but like, you know, the two things that are exempt from all of these actions are validating admission policy and validating admission policy binding. So up to you.
So these actions are actions that can be taken on any Kubernetes object except for policies themselves.
Yeah, I think the way it's done is that you can target a validating admission policy binding onto these things, but the control plane then ignores that targeting. That's quite a technical detail.
Yeah. And it's very technical, and I only half listened to it because I was thinking of my words here. I'm sorry. These actions take effect on Kubernetes objects.
Yeah, like what one is like it's the ones that you bound to. So, you know, when we use these bindings, we might, but well, no, the binding is really where is really where.
Yeah.
So
yeah, it's more where than what.
Yeah, I don't think that's really relevant. I don't know what you want to say.
We'll work it out. On the Kubernetes object that's about to be created.
Well, it might be. So that's not quite true, because it might be a change. You might have an existing object.
Okay. So all this, I'm trying to say. What am I trying to say? That it doesn't apply to validating admission policies and policy bindings themselves.
Yeah, that's the point I wanted to make. That there's that exemption.
So then let's not worry about what's the yes. We'll just say what the no is.
I guess I should say that, you know, if you're watching along on this stream and you know I've got a detail wrong, you should totally pipe up in the comments rather than sitting there hoping I'm going to remember, because I'd much rather see a comment from someone telling me that I've slipped up.
Absolutely. Yeah. Then we can let everyone else know too. Sometimes exactly. I review my boards afterwards, so I can remember everything. And sometimes I see something that was grossly misspelled, and I was like, oh, why didn't someone tell me that? Yes, I would always prefer to be corrected. So great. So we've talked about the old way, the new way, like what's improved. We've defined everything. We talked about some actions, and now we've been talking about the common expression language.
Yeah. You know, how about like, you know, talk about some examples?
Okay, I love it. Yes.
So like I'll just say it aloud, and then we can, like, you might not write down the first one, but like one of them is like object.metadata.name ends with -blue.
Okay.
You might be doing blue-green deploys. So you might say, I want to have, an or condition. The name for my object must end in blue or green. And so object.metadata.name ends in blue, or object.metadata.name ends in green. And I can do that with a CEL expression. What else could I do? What are things when, like, maybe you've got an idea of something that you might want to invalidate, or maybe someone in the comments is like, well, how would I enforce this? Like, we can do a little bit of mini consultancy and solve your problems.
I love it. And we're talking specifically about how to use maybe common expression language to express these things.
Yes.
So I mean, we could go like maybe a container shouldn't be allowed to use, or a pod shouldn't be allowed to use too much compute. I guess you could do that already with a resource limit, or not too many replicas like we talked about.
Well, so let's do two versions of this. But we could say, you've got resource limits, but resource limits are usually kind of per. Well, they could be per different things. They could be per namespace as well. But we might say, actually, we can even go down to the level of containers, and rather than looking at resource limits on a pod, which is what you can do with a resource quota, we could say, hey, you can use up to 1 CPU, but none of your containers in that pod can use more than 0.5 CPU. So if you're using 1 CPU, you have to have 2 containers.
Yeah.
If we wanted to.
Okay.
That is a bit of a complicated rule to write. I will tell you now.
Okay.
But we can do it. I wouldn't pick that one as an example because you'll run out of space.
So what's a good example of a simple one to write?
I'd do that name one, I think, as a start, like limiting a name. So yeah, object.metadata.name.
Okay.
Dot ends with, and the capital W and ends with. You might, I would do that. Oh, lowercase e though.
Okay, gotcha.
So this is, I guess, like this is like classic camel case with the hump in the middle.
Yes.
And then, in brackets, some string you want in quotes.
Curly braces or brackets or the side V
Oh,
things?
sorry. Round ones.
Round ones. Okay. In bracket, and then we'll do this.
They're called parens in America sometimes, I think.
Yeah. Dash blue.
You have to put it in single quotes, which you might be able to fit in because it's a string.
Oh, gotcha. This might be the first time I've written code on the board. Blue. Okay.
And you close the quotes, close the parent. There you are. Okay. That is that's an expression.
Cool.
You could make that more complicated, but we're going to run out of board if we get too much.
Yeah. That's nice though.
And this is very declarative. Go for it.
This seems very human readable, or is it all like pretty easy to reason what the expression might be trying to do?
I think so long as you know what the Kubernetes API is doing. So if you didn't know what an object metadata name is, you're going to struggle more.
Okay.
But in terms of the CEL itself,
was CEL written specifically for validating admission policy, or did it already exist?
It already exists and is used elsewhere in Kubernetes.
Okay. Oh, interesting.
So you can also, this might also be alpha, I can't remember. But when you upgrade a CRD, and you've got a version 1 CRD and a version 2 CRD, you have a similar problem. for built-in APIs, when you upgrade Kubernetes and you switch to HPA version 1 and now you want to use HPA version 2, at some point Kubernetes is going to have to not just know how to do that conversion automatically, but also rewrite that to be stored in version 2, and a whole bunch of complex stuff happens that normally you don't have to care about. When you're writing a CRD, and when you're troubleshooting a CRD, suddenly all this stuff that you didn't want to care about, you have to care about.
Yeah.
And CEL lets you solve the problem of saying, well, I've got this HPA, it's stored as version 1. If the client has come along asking for version 2, what do I do? And you don't think, oh, I've got a rule. I've got a rule that's kind of readable about what to do here.
Okay. Nice.
I think that's either been mooted or done or is alpha, but I'm not sure. And do you know what? I'm going to cheat and look at the documentation. That's what it's for, really.
No, yeah, I think that's great.
Where's it used for?
For what cell is used for besides
inside
besides
Kubernetes
validating admission policy? Okay.
Oh yeah, validation rules in CRDs.
Okay.
So you might not need to use a validating admission policy for your CRD at all. So we talked about the new way, and we talked about how the old way uses custom resources, but CRDs are getting this validation as part of how CRDs work. That's actually beta, so you can use that now.
So okay. Will you repeat? CRDs are somehow getting a cell expression validation now? Is that what you just said? Interesting.
So, we talked for quite a lot of the, I don't know, maybe 20 minutes. We talked about the sort of rules where you make sure that not just that this schema is a number, but also that this number is greater than 0. So you can have any number, but it can't be 0 and it can't be negative. You can use a validating admission policy for that, but you know what? Actually, there's a beta feature that builds that into CRDs themselves.
Oh.
So what we talk about there is not this topic. It's a sort of supporting topic about how CRDs work. There's possibly room under the new way for a little footnote about how CRDs now have this built in.
Yeah, because we're talking about the creators of CRDs are writing validations, validating webhook configurations to do this, and now CRDs creators can use common expression language to write these validations, is what you're saying?
And they can do that directly in the CRD now, not using a validating admission policy. Good thing I looked at the docs.
Can write, should I put cell validation via cell?
Yeah, validation via cell, but it goes directly into the CRD. So, at the API level, you are writing a custom resource definition. You're not writing a validating admission policy at all.
So does that mean that validating admission policy then is more for the use case when you're doing organizational validation?
Yes.
Instead of, because now this dilemma, not this, but this dilemma to validate custom resources is now being solved by validation with cell expression.
Yeah. So the CRD checking is beta. So that's actually, fairly usable, but it's still beta. But I wouldn't swap it for an alpha feature. I say beta.
beta or beta features, those come shipped with Kubernetes, where alpha features do not, correct?
It's common that beta things are switched on, but we actually switched as a project to a policy where beta APIs would be off by default.
Okay.
So only old beta APIs are on by default.
Okay, got it. Excellent. We still have a little bit of, yeah, there's so much to everything. Nothing's a straight answer, but it's all like, what I like about it is it's all been carefully considered.
Something you can do. No, I've changed my mind. I was going to talk about some betas. Yeah, what I would say is that there's another use you can use for SEL within validating admission policy, and that's customizing the error message.
Oh, okay. So we didn't actually explicitly say that SEL can be used to define rules. So, right, that's what it's being used to do.
Yeah. So you define the validation expression. That's what it's really called. It's called a validation expression.
Okay, and then it can customize an error message.
So if just sticking on the validation expression, if it evaluates to true, the object is valid.
Okay.
And
does that work? So if you want to do a mutating policy, you still have to do the old way.
Yeah, there is no mutating admission policy using SEL. Not a thing.
Okay.
But the other thing we were going to say you can use it for is messages.
Error messages specifically?
Or warning messages. So we can have a thing where you're going to send in a stateful set, and you're going to do a blue-green deployment on that stateful set. Let's call it deployment. You're going to do a blue-green deployment, blue-green deploy on a deployment. And one of them is going to have blue at the end of its name, and the other one's going to have green at the end of its name. And we're going to write the more complicated rule that checks for blue or green, because it's not going to fit on the light board, but we know how to write OR expressions. It's like a double pipe, and you can imagine.
Yeah.
And if you've used Python or C, these expressions are going to feel super familiar to you. But yeah, we've got that rule in place, and then you try and create one called application-yellow, because you think they need to be named after colors. And the great thing is that your cluster can be sort of self-teaching. It can be discoverable. And instead of saying invalid request, which is not very useful, or object failed expression, you can declaratively define what the error message or the warning message says.
Helps make failures teachable moments into teachable moments.
Yeah, that's a very good way of putting it. And it's totally true. I think that's you can do that with webhooks, but the amount of time it takes to build that with validating admission policy is super low.
And so I have a question. That is, if our main problem is like, help, my cluster is broken and I don't know why, is this part, the error warning messages here, is part of the solution of that problem that we had? How is, yeah.
I'd say it's like if you break your whole cluster, that's a cluster admin's gonna think of it. So let's talk about the people involved here. So you might have some value delivery teams, and you might have a platform team. That's a really common way to organize things.
Oh, value delivery and platform. Got it.
So, value delivery might be also thought of as DevOps. But what we're talking here is we've got some people who do software, and we've got some people who do UX, and we've got some people who do infrastructure, but they're all focused on an outcome. So if you're like an app for getting a taxi across a city, you might have the team that makes sure that they know the number plate of taxis, and there's like a number plate lookup component, or a taxi vehicle register microservice. And that team, they use a platform because they don't want to go and invent Kubernetes every time someone says we need a register of vehicles. They're like, okay, I work at a big company. Our big taxi company has a platform. We're going to use it.
Yeah.
But then the platform team is setting the ground rules about, well, this is our platform at whichever big taxi company we're at today. And so, it might be, well, look, you can either do blue-green deploys or you can do canary rollouts, but you have to pick one of those things. And if you're doing blue-green deploys, then you label your namespace with, deploy method blue-green, and these rules apply. The teachable moment is for the value delivery people, because they're not thinking about blue-green deploys. They're thinking about, vehicles and registration plates and, city codes or whatever. And if we can if as a platform team, we can make the feedback loop easier for that value delivery team, then they can deliver the value sooner and people are happy.
Yeah. That's great. So but then the question is, how is validating admission policy help in the use case that we talked about when the cluster is broken and it's hard to tell why?
So it can't break.
Let's talk about how it can't break it.
So there's a few things you can't do. You're not allowed to start Bitcoin mining with the message expression.
Okay.
And there's a couple of controls on that. First of all, there's kind of no looping. There's no classic, do while expression. It can't DOS your cluster. Let's start
DOS.
first of all. Let's break it down into what it can't do. And the first thing it can't do is DOS. You just need to change one word.
Oh yeah. Okay. It's too late, Tim. That's okay.
Denial of service.
DOS? Denial of service, and then DDoS is distributed denials.
Yeah, but there's
no.
So distributed is like when the whole internet's trying to do it. But if you just have one team who didn't even realize that was a problem, it's just a DOS.
Okay. So
it can't overwhelm your cluster.
And why can't it?
So there's no, it's not true and complete, and there's an estimator of expression complexity. And you could try and write a very complicated expression that required lots of work to do a validation, and that would tie up the API server. But you would not be allowed to send in that validation rule. So very complicated expressions are forbidden.
And is that within CEL, or is that part of the validating admission policy?
So CEL gives Kubernetes the hooks to check, but Kubernetes makes the sort of the policy decision about the policy.
Okay. So very complicated cell expressions are forbidden by Kubernetes.
Yeah, there are some thresholds on as to how complicated. There's like a score in like some abstract number of complexity, and if you have more than like 5,000 complexities, your rule doesn't get your rule gets stored but doesn't get used. It gets ignored. You get a warning message. I think.
Okay. So it can't break your cluster by overwhelming it.
Yeah.
And it also sounds like you're going to tell us other ways it can't break your cluster.
It can't break your cluster because all of the webhook pods have failed. Or can't. That's like that sounds like the because is explaining wrong, but it can't break your cluster. By do you know what I'm trying to say, right? I'm trying to say that
because the workloads that are enforcing the policy are down.
Yeah,
right?
yeah, because by relying on pods that can fail. I don't know. How do you want to put it?
The workloads that enforce your policy are down.
Sure, yeah.
Is that okay? Yeah, yeah. The workloads that do the actual policy enforcement are down.
Yeah.
And because the policy enforcement is happening by the Kube API server?
Yeah. You've got a cluster of API servers. They've elected a leader. They've done their thing, and they will act on the policies that are live, no matter what. No external help needed.
What's a succinct way to say that?
Is built into Kubernetes.
Enforcement is built into Kubernetes.
Yeah. That, I think, is its true power. This is why it's such a useful thing to have.
This is a big deal.
Yeah, yeah.
Because you might have use cases where your workloads go down, but it's much more rare. Like if you have a use case where your whole control plane or where your whole API server is down, the fact that your policies aren't being validated isn't your biggest problem.
I would add that as a cluster administrator, you can still deny something that you can still set rules that takes things out of that take. You can still set rules that damage business outcomes.
Validating admission policy doesn't protect you from poor judgment.
Yes, it's true. I don't know if you want to write it out, but that is like it's not a magic bullet,
Yeah. I depending on what you have left that you want to cover, I will write it out because I think it's. But if you think there's more important stuff to use with this space that's left,
I would spend the space budget on making that point.
Okay. I'll say, besides the fact that it's alpha, like we talked about how powerful policy is, and it's alpha, so therefore probably too soon to be implementing it. My understanding is the more mature tools like OPA Gatekeeper and Kyverno, they have such community support and so many like rules that have already been written that you can just adopt and adapt for your organization. It helps protect against, I would imagine, the poor judgment piece of it. Like you're like, the community uses this, it works for most other businesses that are like my business. So therefore I can trust that I need something along these lines at least. Maybe I'll tune it for me. And so a validating admission policy, I imagine, doesn't have that yet.
Well, but let's talk in a minute about how we might get there.
Yeah, I love it. Can't Protect your cluster from poor judgment.
I like it. Well said.
Cool.
So a point I've not made is that these APIs, so validating webhook configuration and validating admission policy, they are cluster scoped. They are not per namespace.
Okay.
I don't know where we've got room for that, but that's a point worth making.
Both the policy, the policies cluster scoped,
and the old way and the new way are both cluster scoped.
Oh, I can.
Yeah, cool.
Cluster scoped, both ways.
Yeah.
Yeah, cool.
So if you're that value team and you've got the order a taxi service for your business, how's it going to work? You say, hey, we need a rule just for our microservice that defines how we're going to use endpoint slices. The company has gone dual stack IPv4, IPv6, but we want to be IPv4 only or IPv6 only, and we want to enforce that just for our team. Well, you can ask the platform team and you say, hey, can we have a rule that applies just for our namespace? And that's an option. But what if you wanted it more self-service? Well, these validation rules, they kind of are cluster scoped because they are applied by the cluster. They are naturally, things that fit at the cluster level. But there's a new kind of policy engine that this alpha system allows you to build, where the policy enforcement is managed, but the way you set the policy feels like using Kyverno or feels like using a different project.
I'm not wrapping my head around it quite. Like, what's it normally if you were using Kyverno and you wanted this example, like IPv4 versus v6 in our own namespace, you would have to reach out to a platform person to be able to do it. And so,
sure.
What this is allowing for is for a more self-service way.
So there are some projects out there, not Kyverno, that let you have namespace level webhooks.
Okay.
The old way. You can already have a way to delegate control of webhooks to a namespace. But you then have to trust them, because if that namespace breaks things, they might be breaking your cluster. So we don't want that.
Yeah.
And now we can have the best of the both worlds. This is the dream. This is not what we can offer you today, but this is the future.
So will you help me capture that on the board?
Sure. I think this is like maybe the use for the bottom corner there, which is like, the future. Where are we going? Yeah.
The future. Cool.
And it's something like high-level controllers, wrapping this API.
Wrapping this validating admission policy API. We need like a joke every time I have to write this. Okay. And what?
Yeah, with a higher level abstraction.
Yeah. Okay.
And that higher level abstraction might allow self-service, or it might allow, like, there might be an approval stage. If people might recognize this from their own clusters, it's certainly things that bigger companies might want to do. You have not just a business process for approving changes, but you capture that process in your cluster. Self-service.
Self-service.
There's a lot of buzzwords available here.
Yeah. And then you were talking about capturing a process or Yeah, not necessarily even capturing it, but like implementing a whole process instead of, is that what you're saying?
Well, I'd probably shift to like, because there's not a huge amount of space. The other thing that I would
Uh-huh.
say is that like package solutions, you know, like what
Yeah,
I don't
that's
have
a
the
better
words
way
for
of
it, but
saying.
like there might be a Helm chart, and all it is you know some validating admission policies that people are saying
Uh,
this is good, this is you know kosher.
yeah, like organizational like composite APIs or yeah, compositions. I understand what you mean.
Mm-hmm.
Uh,
Yes, a
uh,
service, you know, like so you could have a company service catalog as well.
package, yeah. Should I put that in addition to package solutions, or it's kind
I
of the
think I
same
would,
thing?
yeah. I no, because there's a
Okay.
slight difference, and we left a gap to come back to something.
I think we have similar brains, Tim. I love how you're into the space on the board. Um, uh, uh, services. What was the service catalog? Service catalog.
Yeah, service catalog.
Cool.
So what I didn't mention, and you know, having covered more of this stuff, and people got, I hope, have got a bit more sense of what a validating admission policy and the actual CEL language code that you have to write. It might only be
Mm-hmm.
3 lines of code, but you have to put your coding hat on. You know,
Mm-hmm.
start the fans going, get the gray
Mm-hmm.
cells warmed up. You can parameterize the policy binding.
Oh.
So I left the middle space for that, but do you want to save that for your
Oh,
face?
here. Okay. I'll just start kneeling down over there. Okay. A validating admission policy binding tells Kubernetes where to use a validating admission policy, and it can be parameterized,
Yeah,
or just like, yeah.
that's all I wanted to say. But you know, it's a little extra detail.
Mm-hmm. What's an example of when you might want to do this?
You might want to let people control the parameter, but not anything else.
Uh-huh.
So CRDs don't cost much money. Like developing a new CRD is pretty easy. So you can
Uh-huh.
develop a CRD which might specify the suffixes that you're allowed. So, you know, blue and green. Because some teams don't use blue and green. They call it red, black.
Uh-huh. Uh-huh.
And you say, okay, well, but, you know, we've got 5 teams that call it blue, green. We've got 17 teams call it red, black. And we've got 1 team that calls it white, gray. Like, this is ridiculous. And we've got this acquisition happening and we're worried what colors they're going to use. So you have one rule and then you bind it with a parameter to say, okay, when I bind it this way, the parameters are blue, green.
Oh.
When I bind it that way, the parameters are red, black.
When it's in this namespace, these are the parameters. When it's in this namespace, got it. Cool.
It doesn't have to be namespaces. I mean, that's the most common thing you would do, you know. But and you could do it by namespace name, or you could do it by, you know, like team labels. There's so much flexibility here that, you know, 2 APIs and an optional API extension mechanism give you this huge amount of flexibility about different ways to hook it all together.
Excellent. Well, we have this little bit that feels like it wants one more factoid, or
Factoids. Okay.
yeah, or we can, if someone wants to contribute, we can point to the community, or if there's something relevant.
Yeah, let's talk about match conditions.
Match conditions, cool. That's nice, because then we're like in a cell column.
Yeah, so match conditions are a rule about when to apply the rule.
And those match conditions happen as part of the validating admission policy.
Yeah.
Okay.
So what that lets me do, I'll just give an example before I do the general thing. let's say I want to constrain config maps apart from config maps in the kube system namespace that start with kube.
Okay.
So I want to somehow, I want to control all of my cluster, and I want to make an important exception because I don't want to break things.
Mm-hmm.
And so yeah, these they let you exempt. They're really about exemptions, and they let you declaratively exempt different things that you're changing from the enforcement.
So validating admission policy match conditions are rules for when you want to apply the rules, but they can also be rules for when you don't want to apply the rules.
Yeah, that's their main use.
Oh, so it's more rules for when not to apply the rules?
Yeah.
It's really both.
I mean, maybe I think it's an exemption thing, but like, what's your view?
Okay. Well, without seeing the resource, I could go either way with it, because it seems like it could be like when something's being created, when you're using then that's when this rule gets applied. When it's being deleted or updated, it's not applied. Right? Is it like that?
So, for example, you could have a wildcard. It's often used with wildcards. So it is really about exclusion.
Okay.
So you could say, I'm going to block any creation or update except for.
Validating admission policy match conditions, rules for when not to apply the rules. Exceptions.
And this is a thing that Kubernetes 1.26 didn't have, and then in 1.27, the latest release, still alpha, we added this. We added a way to look at who's requesting it. So webhooks can do this too, and that can be useful, because you could say, well, I'm not going to let people relabel my nodes. I'm not going to allow changes to node labels once the nodes are running. Except I am going to allow kubelet to do that, because it's the kubelet, and kubelet owns the node API.
I have a question. So what if you are a heavy Kyverno shop or a heavy OPA shop, and you already have policy done up, and now this is happening and it's native to Kubernetes? Like, should you be doing something in response to this update?
So what I'd say is have a think about what rules that you've got in Gatekeeper that might wedge your cluster. And you can migrate just those to validating admission policy.
What does wedge your cluster mean?
So, for example, a very common thing to do is to restrict creation of pods. But you might say, well, I'm going to have a restriction on creating pods, and I'm going to enforce that complicated restriction using my Gatekeeper and Rego code. And it's really important to me because I want to protect my cluster. But that complicated rule does not apply to the namespace called Gatekeeper. In the Gatekeeper namespace, I'm going to use a validating admission policy.
Okay.
Because I can break Gatekeeper, and I don't even know that I've done it. I've just set the trap, and then one day, one of the nodes where Gatekeeper is running fails. And a month ago, I'm going to regret that change, where I changed one of the little rules, and everything was fine. And now the cluster says, right, okay, I need to recreate a pod for Gatekeeper. There's no Gatekeeper running anymore. One of them, there were two running, and then I didn't notice, and then one of them failed, and I didn't notice because I didn't have good observability. And now it's Sunday morning at 3 a.m, and my page is going to go off in about an hour. But my last Gatekeeper pod fails because of whatever reason. Now I've got 0 Gatekeeper pods.
Yeah. So a good first step for implementing validating admission policy, if you already have a good policy solution set up, one you're happy with, is using it to put policy on the policy agent itself. That makes a lot of sense.
And scope it down to that.
Yeah. I don't think I directly said problems with policy agent failure when we were talking about it, so I'm adding it here.
Yeah, that is so you can have that problem with the CRD thing, but as I remembered from Googling during the stream, there's a better answer for CRDs, which is, again, uses CEL, but it uses the same language in a different way. And what's still left is the policy agent failure problem. And that's really, like, it's a very serious thing. Like, your project to implement policies well might be, a week looking at the happy path and 3 weeks looking at all the way it can go wrong and break things just when you don't want them to.
Yeah. Policy is very powerful and therefore very dangerous. If you feel ready, the next thing I'm going to do is do a recap of everything we've talked about today and make sure we have a good view of everything. Cool. So the problem we're talking about is it's actually right this moment now, instead of talking about something in the distant past. So the cluster's broken and it's hard to tell why. And really, we, as you just said, problems with policy agent failure. So we've already recently learned about OPA and about Kyverno and these places that use webhooks at the admission controller layer, either validating or mutating webhooks to do their job. But that involves having those resources running in pods on the cluster. And so for many reasons that can break. The pods can go down, or that node can go down, or anything. And then you're left naked with no policy, and lots of disastrous things can happen. So we talked about why you might want to validate resources. Custom resources need validating, but actually there's a better way to do it. There's a beta feature where you can validate your whoever's creating the custom resources. Those can get validated with CEL directly in the custom resource definition. Yeah. And then also a big reason you want to be validating your resources is for organizational policy. So we talked about the old way. Both the old way and the new way are cluster scoped. So the old way, the custom resource is deployed, and then among other things, it makes a custom resource definition, the deployment on which is the controller, and another deployment, which is the webhook handler.
Can I jump in and correct myself?
Yeah.
Sorry, but because I got kind of sidetracked talking about the old way, I think we should talk about the old way being validating webhook configuration for organizational policy.
Yeah, that's what I was just thinking too when we were going over it. So, okay, I wonder if so the custom resource definition, this is still really lovely information that I didn't really maybe understand all of it before. But the fact, this validating webhook configuration, instead of it being used in the context of validating a custom resource, that's no longer, you no longer have to do it this way. You can now do it with CEL as part of this feature in Kubernetes that you talked about. Actually, will you drop a link in the private chat, and I'll put a link to it in
yes,
in the great. So the old way, yeah, let's update this.
Sure. Are you thinking of getting the eraser out, or I'm not sure? Yeah, I think so. Because I feel like some people get the whole information from looking at the board. I post the board up on a thread on Twitter. And then when I review this information later, I review it from the board. Let me get.
Cool. I didn't.
Cool.
So I'm putting this now into the chat
So this is a
to
link
learn more
to
about this.
the same language, different use, validation rules.
Cool. And so the old way, are we still talking about, so we're talking about to enforce organizational policy. Are we still
Yeah.
talking about custom resources?
No, we lose the CRD, but we still keep the deployment. We lose the controller as well.
So just like
But
any new resource is deployed, right? A new resource.
I would say that what we're having is that we have an organizational policy requirement. The stuff above webhook handler is going to go, and I think basically, and we're going to work out what we should have drawn there if we'd remembered how Kubernetes works.
I love it.
I'll just say a little bit whilst Whitney's doing all of the admin work. Elbow grease. Is that this is the perspective that you get from working in the documentation SIG or the architecture SIG, that you have this very broad view of all these different bits of Kubernetes, but it's shallow, you know. So I definitely know about custom resource definitions and I know about validating admission policies, but I don't know any of these things in huge depth.
So an organizational policy needs to be enforced, right? That's our starting statements.
I think it is. And for this one, it is organization wide. We're not going back to the self-service things and so on. We don't have a story for that yet.
Okay.
We add a validating webhook configuration.
And this can be done OPA Gatekeeper, Kyverno in many ways, right?
Yeah.
But is it likely to be done through a third-party tool like that?
Yeah, you wouldn't write your own. That's like, you know, you install a third-party webhook handler.
Okay.
But the problem is that you could run this outside your cluster. And, you know, you've probably talked about that in, I have watched every stream of yours. So I don't know if you've covered this, but you can run, you know, Gatekeeper, for example, outside of Kubernetes. You can run it on its own computer, and then that has its own failure mode. But of course, if you run it on its own computer, that computer can still fail. Yeah. So you haven't really, you know, you've moved the problem, but it hasn't gone away.
Yeah. Okay.
So yeah, I think the recap then is that the deployment and the service and the pods for the, you know, the tool that you use, that can still go wrong.
So the organization policy needs to be enforced. We add a validating webhook configuration with a tool like Kyverno, and then it makes the following. So it only makes that webhook handler now. It's not also.
It doesn't make those things, but you know, it needs those things. The cluster admin has to install those things.
Well,
yeah. So like the Helm chart makes those things, but like someone sets that up. But the validated webhook configuration doesn't install the Helm chart for you.
My understanding was like with Kyverno, when you write a Kyverno policy, that Kyverno policy, Kyverno makes that policy into a webhook, admission controller webhook. It's running.
But you have to have installed Kyverno first.
So the webhook handler is Kyverno. So
Kyverno is a complicated example because it's also a controller, and there are. So if we went outside the CNCF for a moment and we looked at JS policy, and I'll mention that because you write some JavaScript, and even that has a controller. A lot of these policy engines have two things. They have the webhook config, and they have a controller, actually. So I got you to cross out controller, and then I thought, actually, there's, you know.
Okay.
If the controller failed, you can't change your policies. If the webhook handler fails, you can't do any of the things that the checks apply to. And a lot of the things, you know, something like Kyverno, you typically install it with the webhook matches on like star. So when Kyverno fails, nothing works. Nothing can be created, nothing can be modified.
So when we install a policy engine, for example, Kyverno, it makes this stuff.
Yeah, the installer does that. And this is essential to having it work, you know, being healthy.
All right. So an organizational policy needs to be enforced. When we need to install a policy engine, and we need to add a validating webhook configuration.
Yeah.
And then, therefore, when we install that policy engine, it makes the controller deployment, and then also makes a webhook handler deployment.
Yeah. You know what? I was trying to avoid talking about all that, but I think I should have done because it ended up being, one, wrong, and two, no less complex.
Hindsight's 20/20. But in the end, the bottom line for this part of it is that it's using webhooks, and webhooks, in the end, they can be imperative. They can go off and use any kind of code to do any kind of thing as part of.
Well, one of the things that code can do, so like some of them are declarative, like Kyverno has that declarative mechanism, but you know, some of them are written in where the language that you write the policy in is a form of Python or whatever. And another way that it can fail is that you're not a very good programmer, and your code gets like a null pointer exception or whatever, and that's bad too, because maybe the thing that should be happening is, you know, pods get validated, and what ends up happening is that you have a null pointer exception, and the cluster's broken there. And that's also bad.
Yeah. So there's a lot of things that can go wrong with the webhook itself, but then we also have problems with policy agent failure. And then, like, first of all, you're figuring out how you fail open versus failing closed, which you're just not even worried about failure when we get down the line. And then also when you're dealing the organizational level of validation, failure can be catastrophic. It can break the entire cluster.
This is the dynamic. So now, do you choose catastrophe, or do you choose, okay, it won't fail, but now we're opening the doors when there's a problem?
Yeah. I guess it's an age-old rule or security dilemma, like making something too loose, permissions too loose or too strict, finding just the right balance to get all the security you want, but still make it so the good stuff gets through. So now all that is the context to say, now we have validating admission policy, which is built into Kubernetes and is currently an alpha feature. So with validating admission policy, now the validation is happening as part of the Kube API server. So you don't need a controller and you don't need pods. You don't have any evaluation related workloads running on the cluster. And then you do have two resources, not just the validating admission policy, you also have the validating admission policy binding. So the bindings allow for reuse, because that policy you have written carefully with using cell, you may want to use it in lots of different places, and that's what the binding resource exists to allow for that. So this little bit is backing up to talk about our custom resource definitions being able to be those can now be validated within the custom resource definition itself, and it doesn't need a validating admission policy using CEL, which we haven't gotten to yet in the recap. And that's a beta feature. So finally, the definition, the what is. Validating admission policy is a fully declarative means to define rules about what is allowed or not allowed to happen to an object in Kubernetes. And we said fully declarative because we, like, technically some of these solutions that use webhooks are declarative, but the webhooks themselves don't necessarily have to be declarative. So since this doesn't have webhooks involved, it's not going to any secret space where they're doing Python-like things. It's all in the up and up. It's fully declarative. And then validating admission policy binding tells Kubernetes where to use the validating admission policy, and it can also be parameterized. So then we have validating admission policies can do different actions. One action it cannot do is mutate. So no mutating, just validating. It's in the name. So it can print a warning, so the change still goes through, but you get warned about what you maybe shouldn't have done or what you could do better. It can write an audit record to the Kubernetes native audit logs, and those can be sent over HTTP or written to a file. It can also deny the change, and then that change can also have a message, which we'll talk about. So these actions that validating admission policies can do, they don't work on validating admission policies or policy bindings themselves, which is a safety feature. So you can't make a policy fail, for example. So then we got into common expression language, which is a really big part of how validating admission policy works and how it's able to achieve some of these goals of keeping your cluster unbreakable. So common expression language is called CEL, and it's an extensible, low overhead declarative language for expression evaluation. So it's Turing incomplete, which is a new term for me, but it basically means you can't write general programs with it. So it's limited in what it can do on purpose. So it protects other Kube API users from mistakes or malice. So you couldn't possibly use CEL to write something that would mine Bitcoin on your cluster or something. And since it's limited in scope, it's limited in what you can use it to break. So you can trust more folks to write policy because they can break things less terribly. Yeah. So, we did an example of a CEL expression, which is object.metadata.name ends with -blue. If you wanted to do, say, a canary deployments validation. And then within validating admission policy, you can use CEL for two things. One, to define the validation expression. So basically, if that expression is true, then that it's validated, it passes. Or you can use it to customize error and warning messages, which helps make failures into teachable moments. The validating admission policy also has match conditions, so rules for when not to apply the rules, so exceptions, which of course are very important because nothing is ever as hard and fast as it maybe seems like it should be. And so we talked about what validating admission policy cannot do. It cannot DOS your cluster, so it can't overwhelm your cluster and cause denial of service. So that's, again, because we talked about CEL can't be used to write general programs, but additionally, very complicated CEL expressions are forbidden by Kubernetes. And you said something like 5,000 expressions chained together. It was a pretty big number, I feel like.
It wasn't. There's like a score in like imaginary expression points, and there's a limit. Like
okay.
This expression that we've put here, like the checking whether it ends with blue, would score like 3 points or whatever. But if you go over a number, you're like, no, you can't do that.
Okay.
And it's a nice big number. You can write fairly complicated expressions, but you can't go so complicated you're causing problems.
Yeah, I like that. And it does seem, the more simple ones, at least, if you know Kubernetes, are pretty human readable, which we talked about before, which is cool. So that's one thing validating admission policy can't do. It also can't break your cluster because the workloads that do the actual policy enforcement are down, because there aren't workloads that are doing the enforcement. It's the Kubernetes API server itself that's doing the enforcement. And if that's down, then you have bigger problems than the fact that your policy is not being enforced. So this is a big deal, and pretty much at the core, this and the cell language together are at the core, I think, of what makes this successful. One thing a validating admission policy can't do is protect your cluster from poor judgment. So your cluster still can break if you're using validating admission policy and you just write some silly policy. That's on you, even though you probably, it's on you. I say in the nicest way. So the future, what this enables is wrapping validating admission policy API with higher level expressions that could allow for features like self-service access to policy without having to have a deep understanding of policy tools, packaged solutions, so platform related solutions, and like having a service catalog. And like talking with other policy projects like Kyverno, for example, they already are looking ahead to validating admission policy and how they can use it as part of their solution. So I think it's not, in the future, it's not going to be like your old tool versus validating admission policy. Like all of the older tools that are mature and have big communities are going to be incorporating validating admission policy into what they're already doing. And one more thing we talked about that I didn't write down was if you do want to use validating admission policy and you already have a mature policy solution, one good idea is to use validating admission policy to make policy on your third-party policy agent, so you avoid the problems with policy agent failure. And I think that's a wrap.
I think it's a wrap. That was a really good summary.
Yeah, thank you. You feel happy with it? Is there anything you'd like to change or add?
There really isn't. Thank you very much.
Okay. This was super, super fun. So we're going to dance a little bit to say goodbye. I'm going to replay the intro music and we'll wave our goodbyes while we dance. Sound good? Thank you so much, Tim, for your time and your expertise, for sharing that. And thanks everybody in the chat. Let's get the music going. Yeah. Oh, yeah. Nice, Tim. Your head and shoulders really have some moves.